Mr. Vaibhav Shah, who is the Managing Director at Automated Precisioning for Asia Pacific, India and UAE. With a diversified experience of around 2 decades and expertise in dimensional metrology, Mr. Vaibhav leads an Indian team to provide customized calibration solutions for aerospace, automotive, energy and defense industries. Broad exposure, he is responsible for building a solid network for the brand API. He is an MBA and a postgraduate in electrical and electronic engineering. Mr. Vaibhav also did the senior executive program at IIM Calcutta. Today, Mr. Vaibhav will talk about the importance of calibration for machine tools. So delegates, let's welcome Mr. Vaibhav.
Hi everyone. So today we are going to talk about the importance of calibration for machine tools or robots in general. So the fundamental question is, do you have any of these? Or do you work for an organization where you have machine tools, CNC machines, robots, or even a fixed CMM, portable CMM, any kind of metrology devices, any kind of laser cutting machines, or you have heard about any kind of calibration for these things? What are your accuracy problems? If these are your typical questions in your mind, you're facing any of these departments or you're handling these CNC machines or robots, this is going to be the very fruitful session for you. Everyone else, this is going to be a very big enhancement to knowledge, because we all know the term calibration, and that literally means comparison with a known standard, or comparison of your part, component, equipment with a master. This is the most layman term definition. Now, when it comes to CNC machines or even robots, I would always add robots, because John already covered the sizable amount of automation that's coming in and already existing, and how robots have completely taken over majority processes in manufacturing. So it's worth always considering robots along with machine tools. So when we look at any CNC machine, robots, there are certain areas which contribute to the errors. We always see and expect that the machine delivers the promised specification. It might be 5 micron a meter, or maybe 25 microns over a range of 1 meter for a robot, any of those committed values. But those values are produced when you buy the machine the first time, when you test a workpiece or check an application. But eventually, once you start utilizing or using these machines, they start to exhibit errors, and majority of the time you will not have any clue about what these errors are, or how are these errors creating an impact on the output. So if considering a CNC machine, if you're getting rejections, if your parts are constantly getting cutter marks, chatter marks, you're having serious issues in controlling the dimensions, then that is a very hard way of understanding that there's something wrong. That something can be wrong in the machine, in the process, in the part program, in your tools, in your inserts, in your coolant mechanism, in your motors, in the way your spindle is running. There can be so many contributors, but the largest of all is the machine tool itself, or is the CMM itself, or is the robot itself. So all these errors are classified into 4 different categories. Primarily scale errors, which are all generated out of feed rates, out of your spikes, your backlashes of your ball screw nuts, your positional errors, your servo mismatch errors when you have multiple axis machines. Then comes your dynamic error. These are errors which are induced when your machine starts to move. So it has to overcome a basic inertia and then try to reach from one point to another at a given speed, just like a vehicle. So there are issues, or there are errors related to vibration feed rates, cutting forces, cyclic error, which comes at a particular period of time between 2 axes, and that contributes heavily into the overall performance of your machine or robot. third group is the geometrical group. That is from the construction. Now, whatever brand of machine or robot you have purchased or you're willing to buy, they have their structural definitions, structural details mentioned in either their catalogs, or they do explain the entire kinematic structure of the machine. So it's very important how geometrically this system is, and what's the build quality, what's the structural mass to weight ratios, how much is the straightness, angular, pitch, yaw, roll, rigidity, and the overall flatness in terms of CNC machine head. So these are very important factors. Whereas in case of robots, also the geometrical accuracies are very critical, as whether it is cranks, whether it is link bars, or whether it is the alignment of each of the 6 or 7 axes. Last but not the least is the environment. So the environment plays a major role when you expect a particular type of performance output from these devices. So when you put a CNC machine in a shop floor, which is at 45 degrees centigrade in hot summer, everything is going to expand. So there's a huge impact of this temperature expansion on your machines. There will be equal impact of the pressure, humidity, radiation, local sources of heat, vibration, and overall cleanliness on the machine. So these all factors contribute towards the errors on the CNC machines or on robots or on CMMs or portable machines. And today we talk how are these errors going to impact your production. So fundamentally, they are going to have a direct impact on your overall dimensional accuracy that you expect. Also on your programmed path, if it's a robot, how accurately it's able to achieve that and how consistently it is able to achieve that. So your accuracy and precision is completely compromised because of these errors. So let's study these errors a little bit more in details, and then we straight go to why do you need to do the calibration. So this is a short video explaining what are these geometrical errors, because it's very important to understand this when it comes to machine tools or whether it comes to CMMs or robots.
Straightness, flatness, roll, pitch, and yaw. We will use this graphic to help you visualize each of these errors. Straightness is typically defined as a deviation from the true line of travel perpendicular to the direction of travel in the horizontal plane. If you are looking down on the stage from above and parallel to the direction of travel, this appears as deviation to the left and right as the stage moves through its travel. Flatness can also be called vertical straightness. Similar to straightness, flatness is defined as the deviation from the true line of travel perpendicular to the direction of travel in the vertical plane. If you look at the stage from the side, this would appear as deviation up and down as the stage moves through its travel. In addition to straightness and flatness, there are 3 types of angular errors that a stage will exhibit: roll, pitch, and yaw define rotations about a 3-axis coordinate system. Roll is a rotation around an axis in the horizontal plane parallel to the direction of travel. Pitch is a rotation around an axis in the horizontal plane perpendicular to the direction of travel. Yaw is a rotation around an axis in the vertical plane perpendicular to the direction of travel. Each of these geometric motions is measured using precision equipment on the moving tabletop. As the stage moves through its travel, the variation in each angular direction is measured one at a time.
So here, what you can understand is that in case of any of these errors existing on your machine, you're going to get a lot of inaccuracy on your job. The table itself is having flatness error or straightness error or pitch yaw roll error. You cannot find out on your own. You can only find out from your workpiece or job when you get taper cuts, or when you get chatter marks, or whether you get poor dimensional tolerances when you have to do some end mill operations. You will be able to get those errors, but it's a very hard way, and then you can't pinpoint whether it is 5 micron error, 10 micron error, 20 micron error, which stroke, if it's an x-axis of the machine, which is say 500 mm range, at 100 mm there is an error, at 200, at 400, it's very difficult to identify those things unless you have a tool or equipment with which you can check these errors and then correct these errors. So in general, when we look at the entire CNC machine tool or a CMM, we talk about 6 DOF and 18 error parameters, 21 error parameters. So basically these 18 degree of freedom or parameters is defined using the linear displacement error, which is your positional accuracy, then your vertical horizontal straightnesses, which is your flatness and straightness, and then you have your pitch, yaw, and roll. Plus you have your 3 squarenesses. So you have an X and Y squareness, your Y and Z, and your Z and X. So these 3 squarenesses plus these 6 parameters into your X, Y, and Z all put together is 18 plus 3, 21 errors, which are existing on any CNC machine, which is 3 axis. The moment you have rotary axis on the machine, your errors are going to be further more multiplied because there are additional 2 axes, which is also going to come in. So the next video explains why do you need calibration, the fundamental question, the topic of the day, and it's very neatly explained considering all these different tools.
Every industry has industrial projects that use machine tools. CNCs, lathes, gantries, and more are used everywhere for projects that require tight tolerances, often to within just a few microns. So the machine tools used in these productions must be equally accurate.
In addition to the environment, foundation, mounting, and alignment, there are 21 error parameters for a simple 3-axis machine tool. The linear positioning, vertical and horizontal straightness, and yaw, pitch, and roll all have possible errors in their X, Y, and Z coordinates. Machine tools can also produce errors if they are not square at the XY, ZY, and ZX junctions.
These errors can diminish production quality and can lead to costly rework or parts being scrapped. Fortunately, they can be found and compensated for. The most common form of machine tool calibration, or MTC, is through the use of a laser interferometer, but there are other methods, including ball bars and swivel checks, or the use of a laser tracker for full volumetric error compensation. We wanted to highlight the 7 most important reasons to have your machine tool calibrated today. The first reason is acceptance testing to verify tool performance.
Acceptance testing is similar to laser tracker certification. It measures a machine tool's performance against the OEM stated specifications to validate the tool's performance. Acceptance testing is ideal for machines that have just been installed or have not been run recently.
The second reason is preventative maintenance against future errors.
Similar to acceptance testing, preventative maintenance identifies and eliminates sources of error before they begin to affect the results. Like changing the oil in a car, preventative maintenance on machine tools is about performing routine, scheduled checks, even if they aren't showing any errors. Catching the errors early saves costly downtime and rework later on.
The third reason is to certify a machine that has probing capabilities and their additional error sources.
Machine tools that probe also face possible angular Abbey offset errors. If there's an error in the motion of the probe apparatus, the probe's results will show an error that is often merged into linear error data. These faults can be difficult to diagnose and distinguish from toolpath errors, but they can be compensated for linear and angular error with proper calibration.
The fourth reason is to know your machine's accuracy limitations before you exceed them in production.
Regular machine calibration tests your tool's limits in a low-stakes situation. By pushing your tool to meet its tightest tolerances or maximum production scale in a calibration setting, you can identify the outer limits of its capacity without creating rework or scrap parts.
The fifth reason is to improve accuracies on older machines and potentially extend their working lifespan.
That's right. As with all mechanical things, machine tools erode over time. But regular calibration can often correct many of these errors and extend the life of your tool. Before you begin the costly, time-consuming process of replacing an old tool, a 1 or 2 day calibration from a metrology service provider may be able to keep the tool running for a long time.
The sixth reason is that calibration can help reduce machine waste.
When errors are manageable, parts are reworked instead of scrapped, and that project can continue. But this is a stopgap solution. Rework is still costly for the time spent repairing the part and the waste of materials. Machine calibration can reduce the amount of rework and waste.
Lastly, and most obviously, machine tool calibration creates more accurate parts.
And that's the end goal. Machine tools that are regularly calibrated and maintained produce the most accurate parts. Initial accuracy from modeling to machining has a cascading effect throughout the process, speeding up verification, modification, and assembly. Efficient machine tools allow projects to be completed accurately, on time, and on budget.
Regular scheduled machine tool calibration is essential to ensure the accuracy of the tool, the part, and the project as a whole. Many machine shops elect to purchase MTC equipment like API's XD laser and wireless ball bar, and training so their teams can perform the work in-house. But for many, that is not the most cost-effective solution. For training or contract calibration, API Services has decades of experience with our state-of-the-art MTC equipment and with more than 20 kinds of machine tool controllers. To learn more about MTC and to schedule yours today, please visit apimetrology.com and contact us.
So moving forward, it is, as they explain, if you have components which have a prescribed tolerance, say for example, you have 15 micron, 60 micron on these components. Today you don't know that the CNC machines that you possess, what is the current accuracy of that machine. So when you purchased, it was promised with a certain accuracy, but today, after using it for 3 years, 5 years, 10 years, you do not know until and unless you either calibrate the machine or you verify the machine in terms of its performance by manufacturing a part and then checking it out on a CMM. So majority of the shop floors today lack this knowledge of how important the calibration is. And that is one of the major reasons why they choose the wrong machine for the right part. So if you need a 15 micron accuracy on this job, it should go to this machine. Which is having a 10 micron accuracy. So if you try to put it on a machine which has a 25 micron positional accuracy, you are never going to get that 15 micron. It's going to be very difficult. Today you don't know this. It causes a lot of rework, a lot of reprogramming, constant tool breakages, and constant doubt on anything and everything that goes onto that machine. So the easiest and the simplest option is to just get these all machines calibrated, and we get to know where they stand today. Majority of these positional errors can be compensated. So you can correct these errors in the CNC controller by a very simple method. So API today offers these services with which we can come to your place, calibrate the machine, the compensation, and try improving these machines as best as we can. When it comes to geometrical errors, it is not that easy to correct the machine. It takes some more time because we need to find out the correct area of the error source, and then we still help you in compensating and correcting those geometrical errors. Now, one of the key equipment that's used here is the laser interferometer.
20 error parameters, 6 degrees of freedom, 1 setup.
Now, this is a very simple device, very easy to mount, easy to use. For anyone from this industry who have background of metrology or robotics or CNC machines, it's an added advantage. But if you're just a student who's come out of his engineering and is fresh, he can easily learn this. It is that simple to operate, but the use of this equipment is phenomenal. Ultimately, as an output, you get an accuracy graph. This is how your machine's performing. It also gives you the repeatability of the machine. It gives you the backlash errors. It gives you the positional deviation. And all of this is as per global standards. So we follow VDI, ISO, ASME, JIS. These are different global standards which are used in order to produce the reports for the performance evaluation of CNC machines. So in a nutshell, through just simple instruments, simple service, you can actually check all of these errors on your CNC machine, and you can correct most of them. That helps you in a drastic manner in increasing the accuracy of your parts. So coming to one of the last video that is something about the robots. The API launched very recently this entire RMS solution, which is the robot metrology solution. This helps in a drastic way to calibrate robots. Robots are supposed to be very repeatable system, but conventionally the industrial robots are not very accurate, and that's where we utilize the expertise of the software and our equipments to enhance the complete accuracy of the robot. We work with all the major OEMs. If you have an ABB robot or a FANUC or a KUKA or any brand, it can be compensated, it can be calibrated. We find out the entire geometrical, the global error, moving the robot in a particular volume of the reach of the robot, and then find out all these points using a parallel feedback system, and then calculate the error map. And then if your robot has a compensation enabled, then we load these errors into that compensation and completely correct the robot. So you have a before and after report, and that's how you can enhance the entire accuracy of the robot and its performance. So this is one of the services apart from all the different services. So the question comes is, how do you calibrate your system? And that's where the answer is that you can utilize our services. You can hire us. It's a very simple way to engage with us, whether you have any brand of robots, you have any automation solution in place, you have any CNC machines, any kind of motion equipment, or CMMs, you can just simply call us, schedule a meeting. We'll come find out the issues and we'll suggest you what should be the correction, and then we will implement that correction. So that's our simple cycle. And any questions you have, the floor is open. You can just shoot out the questions now towards the end, and I will be more than happy to answer them. So that's all from API.